What if the ground beneath your feet, the sky above, and the very horizon you gaze upon were not what you've always been told? For centuries, humanity has grappled with the fundamental question of our planet's shape. We've been taught one answer, but what if there's another perspective, one that challenges everything? The prevailing scientific consensus, backed by millennia of observation and rigorous testing, describes our home as a sphere. More precisely, an oblate spheroid, slightly bulging at the equator due to its rotation. This model forms the bedrock of our understanding of physics, astronomy, and navigation. Yet in certain corners, an alternative idea persists: the convex Earth. This concept suggests that while the Earth might appear curved from certain vantage points, its overall surface is not a continuous sphere, but rather a vast undulating plane with localized convexities. It's a notion that directly contradicts established science, but how do we truly know which is correct? Let's embark on a journey of discovery, examining the undeniable evidence that has led scientists to overwhelmingly conclude our planet is indeed a sphere. Consider the simple act of watching a ship sail away into the distance. As it moves further from shore, the hull disappears first, followed by the mast until it vanishes completely below the horizon. This isn't an optical illusion, it's the ship literally dipping below the Earth's curvature. Think about lunar eclipses. During these celestial events, the Earth passes directly between the Sun and the Moon, casting a shadow on our lunar neighbor. Every single time, without exception, that shadow is perfectly round. The only object that consistently casts a round shadow, regardless of its orientation, is a sphere. Now imagine standing at the North Pole, gazing up at Polaris, the North Star. It sits almost directly overhead. Travel to the equator, and Polaris dips to the horizon. Journey further south, and it disappears entirely, replaced by new constellations like the Southern Cross. This shifting celestial panorama is only possible on a curved surface, where your vantage point changes dramatically with latitude. Consider the phenomenon of time zones. When it's midday in London, it's the middle of the night in Australia. This global progression of day and night, with different parts of the world experiencing sunrise and sunset at different times, is a direct consequence of a spherical Earth rotating on its axis while illuminated by the sun. A flat or convex plane would experience simultaneous sunrise and sunset across its entire surface. Perhaps the most compelling evidence comes from direct observation. For decades, satellites have orbited our planet, capturing breathtaking images and videos that unequivocally show a spherical Earth. Astronauts have journeyed into space, witnessing our blue marble with their own eyes. These aren't artistic renderings, they are photographic and video records from beyond our atmosphere. The Earth's spherical shape isn't just an abstract scientific fact. It underpins much of our modern world. Global positioning systems, or GPS, rely on precise calculations that account for the Earth's curvature to pinpoint your exact location anywhere on the planet. Without this understanding, modern navigation from aviation to shipping would be impossible. Our global communication networks, from undersea cables to satellite internet, are designed with the spherical nature of Earth in mind. Weather patterns, ocean currents, and climate models all incorporate the planet's curvature to accurately predict and understand global phenomena. Our very ability to connect, travel, and predict the future of our environment hinges on this fundamental truth. But here's the truly astonishing part. Humanity didn't need satellites or space travel to figure this out. Over 2 millennia ago, the ancient Greek mathematician Eratosthenes, using only shadows, wells, and basic geometry, calculated the Earth's circumference with remarkable accuracy. He observed that on the summer solstice, the sun shone directly into a well in Siena, while at the same time in Alexandria, a stick cast a measurable shadow. This difference in shadow length, combined with the distance between the two cities, allowed him to deduce the Earth's curvature and size. His ingenious experiment wasn't just a scientific breakthrough, it was a profound testament to human intellect and the power of observation. It showed that even without leaving our planet, we could unravel its deepest secrets. The Earth's true shape isn't just a fact, it's a testament to human curiosity, perseverance, and the relentless pursuit of truth. In a world of endless questions, some answers are so profound, they reshape our very understanding of existence.